I do a lot of simulations of chemistry using quantum mechanics, and we tend to write these large files during our simulations, and they can be sometimes multi-terabytes.
From an industry's perspective, we're seeing an exponential growth in the data sets driven by AI. And we're having customers that have gone from having multiple petabytes of data to growing to exabytes of data. And the key thing about having that much data, one, you're going to store that much data, but for AI, I have to be able to access that data fast and leverage it for GPUs.
Being a computational scientist who works on genomics data sets a lot, we have seen exponential growth in data sets for genomics. The storing and processing those data are often incredibly hard with global memory that we often see in HPC clusters.
One of the great things about these types of devices is that you can effectively combine the ingress of data and the archiving of data in a single device, right? So one of the things that we always have to do with smaller devices is that we kind of collect the data inside of these smaller devices and then archive them off somewhere else, whether it be to spinning disk or tape or something along those lines. So something like this allows you to parallelize the data coming in, make sure that you get all the different streams coming into the actual device. You can store it immediately, you can archive it all in the same device, and that can save time, money, energy, and effort.
Imagine 122 terabyte, you can actually play 20 plus million songs using that storage. It has that huge capacity. Now, if you also put that into different perspective, if you recall, today, many of the large language model, they're only in gigabyte. How many actually manifest of those models you can store on those storage? Because remember, before we move those models for training and inferencing, they need to be stored somewhere. And this huge storage capacity will empower you to do your AI use cases as well.
If every node has 122 terabyte SSD in it, that solves a lot of issue. And also, that means you do a lot more research, even at a lot smaller form factor machines.
Being able to have something with this kind of capacity plus the speed, it is amazing.
If you put all of that data on a spinning disk, you're going to take up on the order of hundreds of racks in a data center. As you put it onto a 122 terabyte SSD, not only are you getting the performance benefits of an SSD, which is, orders of magnitude faster, but you're also getting a smaller footprint. So the same exabyte of data on hundreds of racks is probably going to be on tens of racks. And I think that's going to be very important to getting access to the data, but also sustainably growing out the amount of data we have to store.
But with something with that kind of capacity, on a big node with 192 cores like we're seeing now, you could have multiple simulations running side by side and all writing to something with that kind of capacity. And that would be fantastic, because if you're having to write your data over a network to network attached storage, you can swamp the network. But if you had something on a node with that capacity, you could really speed things up by having the data right there where you need it.